Let's learn how to use logarithm table with laws of indices to calculate such numbers. Calculate 2.934 times 72.89 using logarithm table. Solution. We write out the number 2.934 times 72.89. Now the first step is to express each of the number as 10 raised to the power of a particular value. And to do that, means you have to find the logarithm of each of the numbers. So we have 10 raised to the power of, to do that means we have to find the logarithm of 2.934, which is the same thing as having, express this in standard form. 2.934 becomes 2.934 times 10 raised to the power 0. So this 0, we are having it here, 0 point. Now under a logarithm table, you check for 29 under 3, difference 4. When you check 29 under 3, you have 4669 and a difference of 4, which is going to give you 6. So you add it together with this, we have 4675. So we have 0.4675 as a logarithm of 2.934. So we come back here and we write that 0.4675 multiplied by 72.89. So we take the logarithm of 72.89. Now same thing here. Let's express 72.89 in standard form. That's going to give us 7.289 times 10 raised to the power of 1. So this one becomes our integer for the logarithm. So we have 1 point. Now we check the logarithm table. 72 under 8, difference 9. 72 under 8 will be having 0.8621. Difference 9 will be having 5. So we add it together. So we have 8626. So here we have 1.8626 as the logarithm of 72.89. So we write out the, that is 72.89 is 10 raised to the power of 1.8626. Now here we apply the law of indices. Since they're having the same base, we just add up the powers. This becomes 10 raised to the power of 0.4675 plus 1.8626. So we can perform the calculation at the side. 1.8626 plus 0.4675. Now we'll add this up. 6 plus 5, that's 11. We take 1. 2 plus 1, 3. Plus 7, 10. We write 0. Take 1 to the side. 6 plus 1, 7. Plus 6, 13. 3. We take 1 to the side. 1 plus 8, 9. Plus 4, 13. So we have 3. Take 1 to the side. 1 plus 1, 2 plus 0, 2. So we have 10 raised to the power of 2.3301. And to find this is the same thing as having the antilog of 2.3301. And to find the antilog of this number, we only read the value of the antilog of the decimal part, that is 33 under 0, difference 1 in the antilog table. And 33 under 0 will give us 2138. 2138. Then difference 1 will give us 1. So we add it together, we'll have 2139. So we write it out, 2139. But this integer part, the 2, determines where the decimal place is going to be. So since we have 2 here, that means the decimal place will come after the first 3 digits. So 1, 2, 3, decimal point is going to be, and that gives us our final answer for this multiplication. Thank you.